In our third part of class for today, we're going to talk about polar regions, and this involves inequalities with polar coordinates. The reason that we care about these regions is when you take Calculus 3, and possibly, and also a little bit in Calculus 2, but in particular in Calculus 3, being able to draw these regions is going to be really helpful. So I want to give you a couple of examples of these so that you've seen them and they'll look a little bit familiar to you once you get into the calculus sequence. Okay, so in our first example, we are asked to sketch a picture of the region where r is greater than or equal to 1 and less than or equal to 2, and theta is greater than or equal to negative pi over 2 and less than or equal to positive pi over 2. So we're going to start with the r requirements. And so I'm going to draw pictures of the boundaries, which are r equals 1 and r equals 2. So r equals 1. Now what I have here is a picture of a polar graph, which is a polar grid or graph paper, which is really nice for this because I see that I have a bunch of concentric circles. I have the center, which is kind of, we're thinking of that as the origin. A circle of radius 1 is our first circle, so we will mark that. This is r equals 1. And then the next circle outward is a circle of radius 2, and so that will be our r equals 2 circle. The next circle has a radius of 3, and then the last dashed line has a radius of 4. Okay, so those are our values of r equals 1 and r equals 2, and so if I want to shade the region between r equals 1 and r equals 2, then what I'm shading is all of this stuff. Okay. So this is our section which is r greater than or equal to 1 and less than or equal to 2. Now we also have this restriction which is our theta restrictions. And theta, we are looking only at values of theta between negative pi over 2 and positive pi over 2. So here is our positive x-axis, and so, and in fact, I mean, I could even draw the negative x-axis and the positive and negative y-axes in here, and that might be helpful. So I think I'll go ahead and do that. And what we care about is so maybe I'll change this to a different color now. Boop-a-doop. We'll stick with orange. Okay, so our theta value of negative pi over 2 says that I'm going to start by looking at the positive x direction and swing clockwise so that I can mark an angle of negative pi over 2. And then the other theta value that we have is theta equals positive pi over 2, which is pointing directly upwards. And we are looking at all angles between negative pi over 2, and from negative pi over 2 we increase and increase and increase and increase and increase and increase, meaning move in a counterclockwise direction until we hit an angle of positive pi over 2. So we care about the portions of our purple ring between negative pi over 2 and positive pi over 2. So what I really want for this whole picture is I want to cut off that left side of that ring and focus strictly on the right-hand side. So my final picture, which I might draw in some color other than what we've already written up here. Let's see, how about a nice blue? So our region that we care about is sort of this half ring on the right side of our picture, and all of this region inside here as well. And this is our region described by r between 1 and 2 and theta between negative pi over 2 and positive pi over 2. In our next example, we have four graphs set next to each other, and you'll notice that there are different requirements on each of the graphs. Well, actually, there's a different requirement on the first graph, and then the following three are all the same. So let's take a look at the three that are the same and see what's going on there. So in the second, third, and fourth picture, we are asked to graph the region where r is between 0 and pi over 2. And what I notice is that there's no restriction on theta, which means we can have any possible angle we want. Now, when I look at this picture, I see that I have some concentric circles. The blue concentric circle toward the middle, that's our radius of 1. The orange is our radius of 2. The green is radius 3, and the gray is radius 4. So in this case, we are told to shade the region between r values of 0, and r value of 0 would be just this little tiny dot in the middle, and an r value of 1/2. So the radius that we're looking at is a radius of 1/2, which is about halfway between the center and our first ring of radius 1. And so we want all of the points that are included between a radius of 0, which is the point in the middle, and the radius of 1/2. So we get this little dot right here. Alright, now that picture is going to be the same on the next two graphs as well, so I'm going to go ahead and fill those in. And our last one. Here we go. So we have three discs because they're filled in as opposed to a circle which just has an outer edge. So we have these three discs that all have a radius of 1/2 and then are filled in toward the center. Okay, so now let's go back to the first graph, which talks about an r value of r between 0 and 4. So an r value of 0 is right here at the middle, and our r value of 4 will be along the outside. Okay, so this ring just before we hit the edge is a ring of radius 4. So that is r equals 4. And so we're going to shade the entire region on the inside in, but before I do that, I'm going to go ahead and mark the theta values that we're interested in. And so we have a theta value of pi over 6. And so we're going to start at a theta value of pi over 6. And we are going to extend, we're going to swing until we get to a theta value of 11 pi over 6. And that's where we're going to stop. Okay, so I'm going to do a little bit of erasing here. I don't care about the portion of the circle that is not between pi over 6 and 11 pi over 6. And I want to color in this disk everywhere except for that open pi piece which we have cut off. So here we have our picture, and we are going to shade all of this in. There it goes. Alright. And if we shade all of this in, then here is a picture of the region described by r between 0 and 4 and theta between pi over 6 and 11 pi over 6.